Let's look at the sum of the applications, what you can do with the flip-flop or the circuits. First of all, you can create the parallel data storage. So right now this flip-flop is storing the only single bit, but we can attach the multiple flip-flops. So in this case, we have the 1, 2, 3, 4 D flip-flops connected together. So what we have is we have the 4-bit storage, right? Why not? You can use this logic. So we have the 4-bit storage, okay? Or you can actually do the frequency division. What is frequency division? You can actually increase the clock cycle by using this circuit here. As you can see, in this case, what's happening? We have the input, so the input is clock, right? But then the output, the Q negative output, is connected as an input back to the D. Okay, so now what will happen is that your clock will be, your clock cycle will be increased twice. So let's see how it works. So here I created this same circuit. So we have the D flip-flop, we have the input, the clock. So clock is going here. Now, as you can see, the output, this is the output Q. Below you can see here. So if you focus here, this is our original clock above, right? So you can see this is our original clock. Okay, so this is our original clock here going on. The below is now the below one is a output of the flip-flop. Okay, so as you can see, if I stop this, let me stop this here. So the clock cycle is increased twice. So for the original clock, it starts from here all the way here, right? But now for the output Q, the clock cycle starts from here all the way up to here. So meaning the 2 times slower, right? So this could be useful when you, for example, you have some applications you need a less clock cycle. So you can use this D flip-flop and this logic to create this kind of the frequency division application. Okay, so you can do even more. For example, if you attach the one more clock, so let's say that here, instead of here, we attach the one more flip-flop here. So let's do this. So sequential logic, where is the D flip-flop? This one. Okay, so now the output, the input for the clock, we use this one here. Okay, so this one will go back as an input to the original one. And let's see the output. By the way, in this circuit verse, when you want to see the output in a form of the waveform, you can use this flag tool, the flag. So you just click the flag and add it here. So you change the label. So in my case, I want to change it to the Q number 2. Okay, you can change the orientation. So from orientation, I can change it to the left, and I can connect it here. Okay, so now I have let's save this, save offline, save online. Okay, so this is my circuit. Now below you can see all of the outputs. Okay, so I have the clock, the waveform for the clock above. Below I have this one is a clock for the Q1. So let's change the title to the Q1, right? And I also can see the title for the output for the Q2. So if I stop it, so let's stop it here. Okay, let's use the pen. So this is our original clock. So this is the Q1, 2 times less, and this is the Q2 now 4 times less. So the clock is 4 times, the cycle is 4 times longer, but frequency is 4 times the slower. So this is another application. By the way, for example, this one is used later. You can implement for the timers as well, right? So for the timer or for the counter, you can use this flip-flop, right? You can do even more division. This is a counter, as you can see. When you attach using this circuit, so this is the logic using the JK flip-flops. So if you create this circuit, it's very easy. Go to circuit first and try to create this circuit. What you will get is output will be the binary counter. So as you can see, the output is 0, 0, 0, 1, 1, 0, 1, 1. And repeat again, 0, 0, 0, 1, 1, 0, 1, 1. So if you connect the JK flip-flops, you can count up to the 2 power of 3, right? Up to the 8. So if you connect the 4 flip-flops, you can count up to the 2 power of 4, which is 16, etc. So by combining the multiple flip-flops together, you can actually create a real working counter. And that can be used, for example, for the project when you have the counter, right? If you remember, for the washing machine, or for let's say, for example, the traffic light. So for the traffic light, you need the counter. You want to count the duration for the red light, duration for the green light, etc. So you can use this circuit here. Okay, so try to create it in a circuit first. Okay, so this is the binary sequence, right? And this is for the 3-bit 000, 001, 010, 0111, etc. all the way until the 111. Okay, so that is about the flip-flops and the applications of the flip-flop. Okay, so there's another one called the monostable multivibrator, or the one-shot. So this is the name for it. So one-shot. And in case of the one-shot, we have only one state. Okay, so in case of the B-stable, we have the multiple states. But in this case, this one-shot normally in a stable state, and it will change to unstable state only when triggered. So when you trigger it, it will just change the position and then go back to its original position. Okay, so that's why it's called the one shot. So it will change it like the one shot and then go back to the original position. Okay. Unfortunately, we cannot create this in a circuit verse because in this case we have some extra things like the capacitor, right? So in this case, it will hold the value for the certain amount of time, and when the capacitor is full, it will just trigger and change the value and then go back to its original position. Okay, so I will not go into details. You can refer to your book about the retriggerable, non-triggerable. These are the types of the one-shot, and I don't see we will not use this as a practical application during your final year project. But if you want to learn more, just refer to your book or the lecture notes. Okay, so basically that's it for this chapter, right? So these are just the different types of the applications where we can use it, etc. Right? So this one shot, for example, you can see it's used inside the timer called the 555 timer. Okay, so the timer, why it's used as a the regular timer. So you set up, for example, for the 5 seconds or for the 5 minutes. When the 5 seconds pass, it will just create a one shot. It will just send a single signal and then go back to its original position. Okay, so this is where it's used. So this kind of this one shot is used, for example, in traffic lights. So later you can refer to your book. In your book, there's a very detailed explanation of the traffic light logic circuit. So you can actually refer to it and you can create that logic circuit. Okay, so these are just how it works, how the explanations, etc. I will not go into it. And this is actually the traffic light control. So this is if some of you, if anyone wants to create a traffic light, you can actually refer to your book. In your book, 2 chapters, chapter 6 and chapter 7, have the very detailed explanation of the logic circuit for the traffic light. So if you want to do that for your final group project, I'm okay with that, but make sure that no one else is doing it. Okay, so make sure that only one group is doing this. And as you can see, it has multiple different for example, this is a sequential logic, right? Sequential logic, like we say, the flip-flops for the counter, for the timer, etc. Right, so also we have this combination logic. This is to change the colors of the traffic light, right, based on the input, etc. And this is how you're going to create a timer, 5 seconds, 25 seconds, etc. So this is a more detailed logic circuit, and if you go to your book, they have even more detail. They have the inside of each, for example, for this sequential logic, they have a very detailed explanation for each of these components. Okay, so that's it for today, right? So this is a very short chapter, although the lecture note is very long. If you look, it has over 100 pages, but it just shows the different, the applications, different relations, the waveforms, etc. I ask you to refer to your book for more details, but basically what we cover today is we talk about the latches, right? So latches, again, these are the B-stable, the multivibrators that can hold that can be used as a storage, right? So you can store the single bit inside the single latch, and then you can combine them together to create a bigger storage. And then we talk about the flip-flops. The flip-flop is basically same as the latch, except it has now the synchronized input, which is a clock. So we have the clock, and the output is synchronized to the clock. And then we have the different types of the flip-flops, the D flip-flop, JK, etc. Okay, so please refer to your book. See your lecture notes, and inshallah, if you have any questions, just message me. I will try to answer them. and see you in the future. Assalamu alaikum wa rahmatullahi wa barakatuh.